All right, section 10.1. To remind you, we are only going to cover section 10.1 and section 10.3 of this chapter 10. After that, and being quizzed on that, we're going to move on to some stuff outside of the textbook. So just in case you're super excited and wanted to read on your own, make sure you only focus on section 10.1 and 10.3. So this section is on organizing and displaying data. To me, this resembles a lot of stuff you did probably like in late elementary school and middle school. It's basically just being able to read a graph, and we are going to focus on three types of graphs. And when I say graph, I'm not talking about line graphs and parabolas and exponential graphs. I'm talking about the good old-fashioned bar graph, line graph, and circle graph, which in elementary school we made little pie charts. That's basically what it is. It is that easy. It is just going back. ACTs do a lot of using the graphs and being able to read. There's a whole section just on that. They put it like under the science section, but it's very important that you're able to read these and also create them. So the first one we're going to do is the bar graph. So this particular problem from the textbook was talking about the ingredients on a sub sandwich, the fat content specifically. And they were asking these questions. They wanted to know, for example, question number 1, which ingredient contains the most fat? So you'd look at your graph and look at which bar is the longest. Again, my fifth grader, my third grader, and probably my kindergartner would be able to tell me which bar is the longest. And it is that simple. You would simply say mayonnaise because that's the purple one and that happens to be the longest. The second question, how many more grams of fat are in ham than turkey? So you'd have to do a little bit of estimating. Ham really stops right at the bar. So ham is 6 grams of fat, and then they wanted to know turkey. So turkey kind of falls in between. So we'll just say it looks like it's almost perfectly in half. So turkey is 3. So the difference, 6 minus 3 gives me 3. So ham has 3 extra grams of fat than turkey. Next one, how many total fat grams are in this sandwich? So far I've got ham and turkey. Bread looks like it's got 1 gram of fat. I said that this was 6. This is 3. Cheese falls in between 8 and 9. 8 and 10, which would give it 9. And mayonnaise goes a little bit further at 11. So to find out the total grams, you would add up 1, 6, 3, 9, and 11, and you get 30 total grams of fat in this particular sandwich. Now, maybe to kind of bring it up to the high school level, now they're going to make you transfer it into percentages. What percent a specific part of the sandwich is of the whole. So it says, what percent of the total fat grams in this sandwich are from turkey? Well, we just figured out that the total was 30 in answer in question letter C. So that goes on the bottom of your proportion. Turkey had 3 grams of fat. So you can do a couple things here. You can either just simply divide that in your calculator and you get 0.1 and transform that into a percentage, which would make it 10%. You can also, if you wanted to, you could set up a proportion and solve and you would get 10%. Either way, it doesn't matter to me, whichever one you'd like to use, but that's transforming it into a percentage. You're finding parts of a whole. All right, let's look at these examples. Still using this same exact bar graph. Question 1A, which ingredient contains the least amount of fat? Okay, so you look for the smallest bar, and the smallest bar is the red one, which belongs to bread. 1B, which ingredients contain at least 8 grams of fat? Well, at least 8 grams of fat would be cheese and mayonnaise. So we're going to write cheese and mayo. I don't feel like spelling out mayonnaise, so I'm just going to write mayo. And it seriously is that easy. Next, we got a double bar graph. Okay, so same concept here. You're just comparing two things at one particular time. So looking at the questions that they have, the first one, letter A, says, in which year did State College have the greatest attendance for basketball? Well, basketball is the orange one, so I want to look for the biggest orange bar. The biggest orange bar looks like it's in 2003. That's why they put that as the answer. Letter B, on average, how many more people attended a football game than a basketball game in 2001? Now, they're saying on average. So it's okay. There's a little bit of wiggle room. Plus, this is such a large scale that they're doing right here. They don't need, it's not down to the exact person. So you're just kind of given a ballpark of what the difference would be. So in 2001, this looks like for football, that looks like it's about 20,000. The basketball, which is the orange, this comes up halfway in between, maybe even a little bit more. That's why they said 13,000. Again, if you were to write 12,500, that's fine too. And we get, what do we get? 7,500. They said 7,000 because they said that the basketball was at 13,000. Once again, it's a ballpark. It says on average, so you have a little bit of wiggle room. Obviously, if your answer is way off, you said something like 9,000, you're way off, okay? There's a difference between being somewhere in the ballpark and being completely way off base. Saying something like 3,000 for this one, that's definitely going to be wrong. So you have a little bit of wiggle room, just it does have to fall in the area of what the correct answer is. And to protect yourself, you write the word about. About 7,500 takes care of it because literally it's 7,000, 7,500, somewhere in that area. So you'd write about. All right, next it says use the graph to determine which years had the same average basketball attendance. So you want to look for the two that, let me erase some of this stuff, that have the same value. So looking at, let's see, this one and this one, that's 2001, 2002. Also, all the way down here, it looks like 2005 also had the same value, and they all look like they are at about, again, kind of falls in between. I'd say maybe 12,500 to 13,000, somewhere around there is what the correct answer would be. Again, it's if you're way off and you say something like 8,000, that's a big deal. That's a big difference in this particular problem. So the about can only protect you so much. All right, next we're going to move on to the line graph. Line graphs really, when you're doing them, they really have to deal with time. They are the most, when you're looking at a course of time, it's easier to see what's going on when you have the dots connected than it would be necessarily in a bar graph. So anything that comes over a course of time, it's best projected by a line graph. Even our friendly coronavirus graphs that we see on TV, even those exponential ones, they could have a value in February, and then they had a value in March, then they had a value in April. So they could connect them like that. It doesn't necessarily have to be a smooth curve for it to be, to be considered a line graph. They could be exact, and they're also very specific. So when I say very specific, looking at this example, they're talking about temperature over the day. Here it's specific as far as when the temperature was measured. It was measured at midnight. It was measured at 4 a.m. It was measured at 8 a.m., noon, 4 p.m., and 8 p.m. It wasn't them saying, oh, well, the temperature started out at, 59 degrees and slowly increased during the day, getting the highest part around 4 p.m., and then it started to decrease again. That's not specific. If you remember way back when, that was a continuous graph. It was not specific. Whereas a line graph is very specific. So a line graph, going back to my coronavirus example, these would be specific dates. Maybe on February 7th, this is the measurement that they got right here. Maybe on March 3rd, they took another one. Maybe on April 10th, they took another one. Whereas this is just the general, if it's exponential, it was, and they have a curve going on, that is more, it's more of a general, you can see that it's increasing the number of cases, where that one with the specific dates, that's what I'm talking about when I say specific time. Okay, so let's answer these questions. At what time was the temperature the warmest? Well, the highest point is at 4 p.m., so my answer is 4 p.m. During which 4-hour time period did the temperature increase the most? So you're looking for the steepest increase. We don't have to worry about slope. It doesn't even get that difficult here. But if you look, it looks like the largest increase would be in this one. It looks like the steepest line, and that's why they said from 8 a.m. to noon. The next one, use the graph to estimate the difference in temperature between 4 a.m. and noon. Once again, this is an estimate. So let's see, 4 a.m. To me, that looks like, I'd probably say maybe about 65 degrees at 4 a.m. Then at noon, that looks like it's right at 80. And that would give me a difference of 15 degrees Fahrenheit. Next is the double bar graph. The double bar graph, that's supposed to say double line graph. The double line graph. This is where, once again, still time is specific, but you're comparing two things. In this case, they're comparing two airlines, and they're discussing the prices involved in the two airlines. So if you look here, you can see that they both kind of have, you can see where it's lowest for both of them, but you can see generally which one's higher or lower. The blue one tends to be higher most of the time. The purple only gets higher a little bit during two specific months. All right, so we're just reading the graph, interpreting the data. In which months did airline B charge more than airline A? So airline B is the purple one. So I want to see where purple gets ahead. Looks like right here it gets ahead. It's a little scooch more than the blue line. Looks like this would be the second one right here, which that would be April and September. You'd have to translate this JFMAMJJASOND. That's the months of the year. Next, question B, during which months did the airlines charge the same airfare? So the same airfare, let's see, looks like May. This one doesn't quite look like it because you can see that the blue is just a little bit more. So just like they said, I agree with them that it would just be May. If you had to, maybe zooming in on it more, you could kind of see that the blue is just a little bit higher. Next, it says, use the graph to describe the general trend of the data. Well, now I got to look overall in these. What I can really focus in on this, and this is very true, is during this time interval, they both airlines increased their prices. That was the highest months that there were. That's June, July, and August, because typically when the world is not closed under quarantine for a virus, normally people travel in June, July, and August because you don't have school, and that controls a lot of things that are going on. It's a popular time for travel. So as you can see, the prices are going to go up because if you're an airline, you're going to charge a little bit more money, so that way people, they make more money. You can also see an increase over here in December. And the reason why December would be increased is, again, the holidays. That would be a time where prices are going to go up. So those are two trends you could write out or you could notice. You're going to have a multiple choice test on this. And even when you do take important things like the ACT, where they have a lot of graphs on them, it is multiple choice. So you'd probably be reading the answer choices and describing which ones are trends of the graph, which ones are not trends. Generally speaking, I can say that airline A looks like it seems to be the more expensive airline outside of April and September. 2 months, the other 10 months out of the year, it's more money. So you're just describing the different trends that are going on in a graph. All right, our last one is the circle graph, which growing up, you would have referred to this as a happy little pie chart. We are now grown up and we're big boys and big girls, and we call it a circle graph. So we sound all sophisticated. Now, usually you're going to use this when you have different parts of a whole. So in this little example here, what they're trying to show you is a fruit salad. So when I say parts of a whole, I'm talking about these are different ingredients that make up one fruit salad, one item, whatever it may be. So it's parts of a whole is what you want to think about when you would want to use a circle graph. It does, the picture itself, looking at it, I can kind of just glance at it and I can see that without even looking at the numbers, and if I just look at the colors of the fruit, I can see that cantaloupe is the one that's used the most, that has the most cantaloupe in this particular fruit salad. If you grow up and you get a job and you have to do presentations and you have to deliver information to maybe your boss or to a group of people, or you have to teach them something and you have to tell them how something is broken down. Instead of fruit, it could be sales. You're working in sales, and this amount of your yearly profit goes to this, and then the other one, you may want to depict it with a circle graph. Or maybe what another backup could be is sometimes you can use a bar graph. I could have done the same thing with a bar graph, and you would have seen, okay, cantaloupe is up here. Let me get rid of my highlighter. If I had a bar graph, okay, so cantaloupe could be up here. Next, bananas and strawberries have the same amount. Then I've got blueberry, and then I've got just a little bit of kiwi. So you could do a bar graph. It is possible. You would not do a line graph. A line graph does not, again, this has nothing to do with time. You're not breaking up anything with time. So the reason why I keep saying this and describing when you would use this, because in the next type of problem, you're going to have the choice. You're going to have to pick which type of graph would be the best for a certain particular set of data. Okay, so answering these questions, which two fruits together make up half of the fruit salad? Half of the fruit salad, that would be bananas and strawberries. Which fruit is used more than any other? I just said that, cantaloupe. Again, you can eyeball that one. If not, you could compare. You've got 2.5 cups, and the other ones are two cups, 1 cup, and a half a cup. So you can clearly see cantaloupe is the most. Now it says use the graph to determine what percent of the fruit salad is cantaloupe. So going back to the first example I did with bar graphs, when we were adding up and figuring out how many fat grams were in turkey, I do have to do the same thing. First of all, I have to add up how many cups there are in this salad. Bananas, strawberries, I'm going to make it 2.5 just to make my life easier. 1 cup of blueberries and half a cup of kiwi. So you're going to add 2 plus 2. That's 4, 6.5, 7. I've got 8 cups of fruit. Now, out of those 8 cups, 2.5 of that is going to be cantaloupe. So again, it is your choice whether you want to set up a proportion, or if you want to set up, or just type that into your calculator, what 2.5 divided by 8 is as a decimal. That's 0.3125, which converts to 31.25% of your fruit salad is cantaloupe. All right. Moving on, you have the next type, which is choosing which type of graph to use when you're given a set of data. Now, sometimes there are more than one choice, and both choices would be correct. There's certain times the line graph is really specific. When it's going to be a line graph, you're going to deal with specific timing. Bar graphs and circle graphs, you can kind of use those interchangeably. So how you answer it isn't going to be necessarily marked wrong because they drew a bar graph and you wanted a circle graph. Again, on your quizzes for me, I can't have you draw a quiz. I mean, I can't have you draw a quiz. I can't have you draw a graph. In quizzes, I can't do that. So it's going to be drawn for you, and then maybe the question might be, which of the following graphs is the best representation of the data? And then maybe answer choice A is a bar graph, B is a line graph, C is a circle graph. So that's how you'd be presented the information. Okay, so in this one, it says use the given data to make a graph. Explain why you chose this type of graph. So here we have different types of animals in a, I don't know if it's a farm or a lot just livestock. I don't know enough about animals to know if that's a farm or what that is, but it's just, oh, they're entering a show. My bad. They're entering a show. So we got all the different show entries of different livestock. All right, so this very simply, you've got different numbers. A circle graph would work on this. However, bar graph is a little bit better just because it is very clear what's going on here. Line graph, once again, we're not talking about time, so I wouldn't go near a line graph. Best choice is a bar graph. I'd say, you know, a second choice would be a circle graph. It would just take a little bit more work for you to put it in it and draw a circle. So again, you could pick between a bar graph and a circle graph. Okay, the second choice here, we do have it presenting as a circle graph. Now, division of crops. The reason is because you have one farm or one crop, and it's how it's distributed in between the different types of vegetables that are grown in this particular farm that's going on. So the categories, it is showing parts of a whole. Each one of these are parts of the farm, okay? 25% is fallow. I don't even know what fallow is. Corn, 15% is wheat, 20% soybeans, and 5% is mixed vegetables. A bar graph wouldn't be terrible here. The one upside of choosing to use a bar graph is you don't need to transform everything into percentages. The percentages would definitely make it more work if you were going to do that stuff. This part right here where they're having you divide it into a circle, that right there is we're not going to do that where we're finding out the different degrees because we're not using a compass. We're not going to do that. You would have to title the graph and label each sector, which by the way, each little piece of the pie is called a sector. So the corn sector is 35%. So if you had to draw this in the real world and you had to come up with your own, because we're not going to be using a protractor or a compass to draw a circle and make it perfect, you would more or less have to kind of eyeball it. You'd look at it. You'd see that the greatest amount was the corn. Okay, so it's not quite half or a quarter. A quarter would be 25% and that would be half. I want a little bit more than that. So that's where I'm going to go right there. You'd label it, say, okay, 35% corn. So that kind of thing and so on. And you'd go and you'd fill in all the other pieces of it. All right, here is a timeline one. And you know right away, here they're talking about years. And you would clearly just connect the dots. This one, again, when it's talking about time, that's when it is the easiest to know which type of graph to pick. So this example right here, I had to cut and paste. It's not one that you get to see. It's one that I saw that I thought it was a good example. It says use the given data to make a graph. Explain why you chose this type of graph. Right away, we're talking about years. So in 1880, there was 265 farms, 1920, 238, 1960, it's 124, 2000, there are 53 farms. So the number of farms is obviously decreasing on this particular one. We're talking about time. So time would be when you're showing changes over time, the best graph to use would be a line graph. So that one's very specific. I would not do a circle graph. Circle graph would not make any sense in this one at all. So don't go near that one. Bar graph is not the best one. If they were comparing maybe they were comparing two different types of farms, maybe zucchini farms and I don't know what other kind of vegetable, corn farms, okay, corn, where they grow corn. Maybe in that respect, you do a double line graph or you could do a double bar graph in that circumstance. But this one is a single line graph. What I want you to do right now is I want you to go work on page 639. Or actually, I'm sorry, it's not 639, it's 691. 691. And you are going to do questions 2 through 16. Actually, it goes to 692. And you're going to do 2 through 16 all. They're quick. You're just answering questions. And then we're going to come back to Zoom and we'll go over the answers to those questions.